As an Ansys partner since 1984, we are highly committed to helping you design, simulate, and succeed.
Hello everyone. Today we'll be talking about associativity between SolidWorks and Ansys Fluent using Ansys Discovery as an intermediary. The process is going to allow you to solve an initial design within Fluent, then make design changes in SolidWorks without losing any of the prep work done when setting up your CFD analysis within Fluent. In this model, we have flow through a duct with a fan and fan shroud as part of that ductwork. The geometry consists of a duct body, the fan, and an MRF boundary which separates the rotating and stationary regions. Let's say we've already done our first pass of this analysis. In our first design, we took the geometry over into Ansys Discovery, applied our name selections, which are our flow boundary conditions, as well as shared topology to create watertight regions of space. We passed this over into Fluent meshing, where we used the watertight geometry workflow to create a highly efficient mesh. We brought that mesh into the solver, set up our boundary conditions, and solved our model. We looked over the results and say that while the performance was good, we'd really like to improve it. One thing we may want to do is back in SolidWorks is to change the diameter of the fan shroud. Let's say that within that first pass we saw there was a lot of backflow around the tips of the blades, and so we'd really like to reduce the gap between the blade tip and the fan shroud. I've already got a cut lined up, so keep your eyes on the center of the screen as I change the shroud dimension here. There you can see it shrink down to meet up closer to where the blade tip is. We're then able to save that geometry, and then here within Discovery, we can use the history tracking feature in order to update that design. Again, see, you look here at the center of the screen, and as we update the geometry, you'll see the fan shroud shrink down to meet up with the blade tip. We can then hit the play button here in the history tracking feature to have it recreate all of our modifications that we did within Discovery. This allows us not to lose any of the work, and we can just pass this geometry then onto the mesher. We'll reuse all of our mesh controls and setup that were done previously within the mesher, just generating our new mesh, pass that into the solver, reuse all of our boundary conditions, and resolve our model. Once we have our two designs comparing the two results, we can see that after we reduced the gap there between the blade tip and the shroud, we did in fact reduce some of the backflow that was happening there around the blades. And if we look at the performance, we can see that we actually increased the vacuum upstream of the fan by about 12% just by reducing that gap for the same flow rate and fan speed. If you'd like more information on associativity between SolidWorks and Ansys, we have a recorded webinar on our website covering the same process in more detail, as well as the associative workflow between SolidWorks and Ansys Mechanical. You can find this and other webinars on our website by following the link below.
Contact us today to discuss your unique physics challenges and find the right Ansys tools for you.